hopefully this works. If it does, there will be a video online about what we're about to go through. If it doesn't, I don't know. We'll see. I don't know that I want to redo this video. I already have to redo another video because my Chromebook wasn't working very well. Let me get my pointy stick. Y'all, I dropped my laser pointer and it broke my first week, and now I don't have a laser pointer. And now, after like a couple days of a laser pointer, I feel like I need it. So, just like right here, it's like on the counter and it fell off the counter and it doesn't work.
You want those like big laser pointers?
Well, we need big laser pointers.
They look like a flashlight.
Oh no, I don't want nothing that big. They do have a pretty cheap 3-pack on Amazon for messing with cats, but I think I'd like one that also changes the slides. We'll see. Anyways, I don't have a laser pointer, and apparently this is not doing it. Why is it asking me to do this? Am I still recording? Is it recording me right now? Yes, it is. Okay.
Please leave that.
Oh yeah. No, I don't edit my videos. They're raw, straight from the classroom. So what we have today is the exploration. We've all done the exploration plenty of times, so you kind of know how to get to it. But I have assigned the reading. So first step, click on the reading and open that up. Second step, you're going to go ahead and click on explore. Click on explore more resources because we're doing the exploration. Just everything is the word explore. And then explore yourself down to the bottom. And you will find the exploration causes of earthquakes with the green image. Go ahead and click on that, and it should open it up in a new tab so you can look at the exploration and the reading at the same time and kind of work your way through it. So I don't think we have a lot to do here. We got matching. And so basically we're talking about earthquakes. We're talking about whether stuff has been squeezed or pulled. So if we come back here and we go to page number 3. What? This is not the right thing. Here. I'm the wrong. Anyways, let me just come back here. It doesn't matter. Let's click on causes of earthquakes. Here's where we're at. So, no, I was just on the wrong tab. Here we go. Sorry. Having a little bit of technical issues today. So we come back here to the third tab under Explore. Tab number 3. I think this is going to give us what we're looking for if it goes there. Elastic rebound theory. No, actually, it's tab number 4. So tab number 4 gives us our strain and stress in the Earth's crust. And if you scroll down here, they give you the 3 types of strain and stress. You have tensional stress, which means tension, I'm pulling things apart. I'm trying to separate it. So if it were like a piece of clay, I would be stretching it out, pulling it apart. Compressional, I'm squeezing it together. I'm trying to push it together and I'm compressing it. And then shear stress is where they just go back and forth. I'm not pushing or pulling. I'm sliding them next to each other. And so it's almost like a twisting stress, but we call that shear stress. So those are your 3 types of stresses, and they're going to do different things to the rocks. And so what the lab wants us to do, if we go back to that page, is basically like a little matching game. You want to match the stress with what type of thing is going to happen here on your, like in your rocks. So one of these pictures, this isn't the greatest picture, but what I think this is someone pulling a rubber band. So they got their fingers hooked and they're stretching this rubber band apart. And so something that pulls stuff apart is going to be tension. Tension is going to be pulling stuff apart. And so when I click both of those, it tells me I'm right. Let's reset this. What else do I have? Compression is going to be like squeezing stuff together. And so I'm not sure exactly what this is, but it kind of looks like a balled up piece of tin foil. So I'd imagine that is probably compression. So if I click on that, it tells me that's right. The buckling of metal is an effect of compressive stress. So I can reset. What's the difference between start over and reset? I guess they just mix them up. Maybe I shouldn't have started over. Anyways, let's just do this real quick. Tension here. No, tension here. And then compression here. And then what else do I have? I have another compression. I've got a crack in the road. A crack in the road, especially this crack looks like it's been opened up. That's not going to be compression. Compression is when I'm squeezing, so I'm not going to have like an open crack there. That's probably going to be tension. It's hard to tell what this is, but this kind of looks like a crumpled up piece of paper also. So I got crumpled up tinfoil, crumpled up paper. I'm going to guess that's going to be compression. What did it say? Oh, they're not telling me. Was I wrong? Maybe I was wrong there.
You didn't click compression yet.
Oh, I thought I had. All right, I guess I clicked the same compression. I see. So I got my two compressions. I got a tension. I'm gonna guess this is gonna be tension because it's opening up a crack, so things are separating away from each other. So that seems like pulling apart. So I'm gonna go tension on both of those, which is correct. And then what do I have left? I really have two shears and two images of shears. Which they're just kind of cracks in the ground. The cracks aren't really opened, so they're not pulling apart, and they're also not like crumpled up like we saw with compression. They're just kind of cracks, and what that is each block sliding next to each other. So the last two images are both going to be shear. It looks like cracked metal and kind of like a cracked rock. So now we have these organized. We got our two compressions, our two shears, and our two tensions, and everything is matched up. It says yes, so let's proceed. So now to the next part, they give us an actual city, and they tell us, they give us some options to do. So I can apply compressional, tensional, or shear stress, and I can pick a type of fault, a reverse or a thrust fault. So we're gonna go compression, and we're gonna go reverse fault, and we're gonna trigger this, and it's gonna show us what kind of earthquake's gonna happen. So you can see the ground being squeezed. You can see the rocks start to buckle before they break. So just like the rocks that I talk about, like with the wood, as I squeeze it, the wood's going to bend before it starts to break. Then once the break happens, I have my actual earthquake. And so all that energy is released in the earthquake, and it goes out in waves everywhere. So they're asking us something else. Let's click view location. So here they show us, when we squeeze it, you get that pressure that builds up, and then once it slips, I actually have the hanging wall of my fault go up, and the foot wall, the one on the bottom, goes down, and you can see that split at this white layer right here. This is a layer of quartz. It comes over here, but it stops, and it picks back up top there. So you can see that they've had displacement here on the fault. And I guess that's all we're doing right here. So start over. Oh, I started all the way over? What?
Oh.
Hold on. Close that. Boundaries. What are these boundaries? What do we do over here? So they got all our different plates. They have the plate boundaries in between them. What do they want us to do? Just view all? Okay. They show them to us. Then we can hide them. And then we can proceed. Examine the image or animation below. Identify the stress that is associated with the plate movement. Then identify the types of faults that form as a result. So looking down here, my plates are moving together. You can see one of them is being pushed underneath the other one, but these two arrows are pushing together. And so pushing together is going to be compressional stress. So I know it's compressional stress. It's either a thrust fault, a normal fault, or a strike slip fault. And if you look back in the reading, compressional stress will lead you to thrust faults or reverse faults, but not shear ones. I don't know if they talk about it on this page. It might be one of the previous pages. But yes, this is going to be a thrust fault, and if we click that, we can submit it, and they will tell us we are correct. Yay, correct. So I guess they have a couple of these. Here's an example of shear stress. You can see nothing's going up or down. We're not separating apart or pushing together. They're just sliding side by side. That's going to be our shear stress, and it's going to be a strike slip fault, and we can do that. So you can work around in this a little bit. I thought that it was going to be a little bit more straightforward, but I'm not sure what they're trying to get us to do here. So let's take a look at the questions. Question number 1. Define the terms stress and strain. Explain how they are related. So we're going to come back to the reading here. And that's not the room. Let me just close that. Here we go. We want to define the term stress and strain and how they're related. So they have your terms right here on this page. This is the 4th page of our Explore tab. So stress is any force that results from gravity or a plate motion. So stress is just a type of force. If I squeeze something, if I pull something, if I twist something, those are all types of stress. So stress is any force that results from gravity or from plate motion. Now strain, we search around and look for the definition of strain. It might be on the next paragraph here. Yes, strain is the deformation caused by the stress. So in this stick, the stress is me pulling at it and making it bend. The strain is the actual bending of the wood itself. So the stress is the force, the strain is the result. And so I can stress something, but if it's strong, it's not going to strain. So like if I push on this wall, I'm stressing it. I'm putting force on it, but is it moving at all? No. So I'm not straining it at all. I'm only putting stress on it. But with the stick, if I put stress on the stick, I get strain because I'm getting that deformation. So strain is the actual movement. It's the deformation caused by the stress. So those are your two definitions. And what do they ask us to tell you the difference between the two? Explain how they're related. The definitions explain how they're related. Stress is the force. Strain is the result of the force. They're all related. Number 2, and further types of stress that has caused changes in the original shape of the object given below. So this is going to be a little bit different. Let's start with the middle one. So you need to tell them about all 3 shapes. They don't like give you numbers or anything. So we're going to call them left, middle, and right. This is my original shape. So what's the difference between my original shape and the middle one? What's happened to this square to turn into that? It's gotten pushed. Yeah, it's gotten pushed down. It's a little bit wider, but the main thing I see is that it's shorter. And so the only way to make it shorter is to squeeze it. I'm adding a force from the top and I'm squeezing it down like you would push down on something. And so the middle one, I would start to type in here, the middle deformed shape is due to compressional stress. So the middle deformed shape is due to compressional stress. I'm squeezing it, I'm compressing it. What about the shape on the right? What has happened to make the shape on the right the shape that it is compared to the original one? What did they do to it? Yeah, they pulled it. Because you could squeeze this from the sides, but really it's not going to be that tall after you squeeze it. And the same way when I squeezed this one, it didn't go real wide on the flat. It just kind of shortened out. So I know that to get this shape on the right, they probably pulled at it. They pulled at it from the top and the bottom and stretched it out that way. So I would say the deformed shape on the right side is due to tensional stress. Pulling apart tensional stress is what got me the right shape. And then the last one. The box is pretty much the same shape and size, right? The only difference between the left deformed shape and the original shape is a little crack in the middle. And so if we go back to the reading, that's just kind of like our default one. Tensional stress pulls stuff apart. Compressional stress puts it together. If it's not pulled apart or pushed together, it's going to be shear stress. And so that's what happened to that last one. It's shear stress for the left deformed shape. And that is what caused that little crack to start to go through it. So middle shape was compression. The right shape was tension. And the left shape was shear stress. Shear stress. Shear. Number 3, compare and contrast normal and reverse faults. So if you go back to page number 2, I believe, to what we're talking about here. Yes, talk about faults on page number 2. The way we talk about faults is the hanging wall and the footwall. We kind of went over this before. The foot wall in the very generalized blocks looks like a foot or like a shoe in a way. The hanging wall is the one that's on top, and it kind of has an overhang over the other one. And so the way these faults are designed is, what does the hanging wall do and what does the foot wall do? And if we look down here, they're going to give us some explanations. In a normal fault, the hanging wall moves down relative to the foot wall. So that's your normal fault. In a normal fault, the hanging wall moves down relative to the foot wall. In a reverse fault, it's the opposite. The hanging wall moves up relative to the foot wall. So in a reverse fault, the hanging wall moves up. In a normal fault, the hanging wall moves down. And so they're essentially opposites. One's going to go one direction, the other one's going to go the other direction. So make sure you talk about the hanging wall. Reverse fault, the hanging wall moves up. Normal fault, the hanging wall moves down. That's the difference between the two. In the exploration, select the shear ratio. Oh, let me put this in. You should add this in too. In a normal fault, I come back up here. Do they say it on here? Yeah. In a normal fault, I have tensional stress. So make sure you say that the hanging wall moves down because there's tension. It's being pulled apart. That's why the one goes down. And in the reverse fault, it's compression. So in a reverse fault, I have compression, which makes the hanging wall move up. So make sure you put that in there because that's the main part. That's the difference between reverse and normal faults is tension versus compression. The hanging wall moving up or down is just a result of that. So sorry, back to question number 4. In this exploration, select shear radio button option in the apply stress section, and then click trigger button. Observe and explain what happens. Okay, so let's go back up here. Shear radio. I don't know that it says radio. Let's just do one of these. Shear is going to be, no, that's not right. Shear is going to be this one. So I got the shear. Do I have to do all this again? Oh, frustrating. Tension here, compression, compression. Okay, now I proceed. Now I want to click the shear. I assume they're saying radio. Why radio? I don't think that's right. Anyways, trigger this. We're going to trigger a shear earthquake here. We're triggering it. And you can see nothing's going up or down. There's no hanging wall or foot wall. They're just sliding next to each other along the fault line. This is your shear stress. So it's not pushing together. It's not pulling apart. It's moving side by side. That's what we call shear stress. And the question asks us, what happens? What happens in the earthquake? Let's see. What's a good way to describe this? Let's see, what do they want from us? The next one is shear stress radio. Apply stress section, and then click trigger button. Observe and explain what happens. I would just say, I don't know, how do you describe this? I'm going to describe a video. I would say the block on the left moves towards the screen. The block on the right moves away from the screen. And a fault is created in the middle where the earthquake happens. I would say something along those lines. That's a decent explanation. So the block on the left moves towards the screen. The block on the right moves away from the screen. And a fault is created right in the middle, which is where your earthquake happens. And that's good enough. Number 5. Identify the type of fault and the type of stress that has caused the offset of the strata and the image below. Okay, so if we see this, let me just draw this on the board because it's not a great picture, but we can still see what's happening. Basically, you have a little square like this, and you have a fault running through it like that. And the layer, what I'm looking at, there's that A layer and that B layer. So the A layer over here is higher. If I fill this in, A layer's right here, and then the B layer's like down here. And so you can see that relatively to each other, this one has gone up and this one has gone down. Because I know that layer used to be straight. It used to connect all the way through. That's what has to have happened. So this one has to have gone down. This one has to have gone up. If this is the hanging wall, and this is the foot wall, then my foot wall went up, right? And so that tells me that this is a normal fault. Because if I go back to the reading, I go to the faults. In the normal fault, the hanging wall moves down relative to the foot wall, which means the foot wall moves up. And this is extension, so it's from tensional stress. I'm pulling things apart. And so that's what I want to write in my answer. Identify the type of fault. This is a normal fault because the foot wall has gone up, the hanging wall has gone down. So identify the type of fault. This is a normal fault. The type of stress, this is tensional stress. It's being pulled apart. So normal fault with tensional stress that has caused the effect of the strata in the image below. Label the hanging wall and foot wall and the direction of movement. What could have caused the stress that formed this fault? So you can't label anything in yours. Just say the hanging wall is on the B side. The foot wall is on the A side. And what could have caused the stress that formed this fault? This is just in a couple rocks, so I don't think this would be like plate tectonics. But you gotta have something pulling your land apart. And so if you had two tectonic plates moving away from each other, that could cause this kind of stress. So I would just say, what could have caused this type of stress? Two tectonic plates moving away from each other could have caused this type of stress. So again, it's a normal fault. It's tensional stress. The hanging wall is B, the foot wall is A, and two tectonic plates moving away from each other could have caused that stress. Okay, next, number 6. Define the terms focus and epicenter. So if we come back over here, I believe those are going to be on that first page. Let's go back to page number 1. And here, they're going to give us the definition for focus and epicenter. I believe somewhere in here. Did they not do it? Surely they did. Pressure builders talking about an earthquake. Plates collide. They didn't give it to us here. So I can start to explain it while I look for it because it'd be nice if I could find a good picture. The focus is where the earthquake actually occurs and is almost always underground. So the focus is where the earthquake actually occurs and is underground. The epicenter is the point above where the earthquake happened on like the surface. So like on a map, where do we show on the map where the earthquake happened? That's the epicenter. So the epicenter is just above the earthquake at the surface, and it tells us in relation to where we can go where the earthquake happened. But it doesn't really describe how deep it is. So the focus is where the earthquake actually happened below the surface, and the epicenter is where the earthquake shows up on the surface at like on a map. I don't know. There's probably a better way to say that, but Discovery Education doesn't even tell you about focuses or epicenters. They just ask you questions about them, apparently, without any information. So thanks a lot, Discovery Education. Okay, number 7. Describe the types of stress associated with each of the 3 types of plate boundaries. What types of earthquake movements and faults do you expect at these boundaries? So You just need to give the 3 types of stresses and the 3 types of faults that come along with those stresses. So page 4 is what we're looking for. We're already there. These are our 3 stresses: tensional, compressional, shear stress. And so if you scroll down just a little bit, they'll give you the types of faults. So, well, never mind. I guess they do that on the other one. Let's see. Do they say it here? No. So let me go back. So we got tensional, compressional, and shear stress. If we go back to the faults, they will probably give that to us there. I was on the wrong page after all. So our 3 types of faults on page 2. Apparently, there's so many pages. I'm just getting.
Are we gonna do number 11?
Mixed up. No, we will not do number 11. Just 1 through 10. So here we go. Normal faults are going to be compressional. So is that all they want? The 3 types of stresses and the 3 types of faults. Describes the types of stress associated with each of the 3 types of plate boundaries. What types of earthquake movements and faults do you expect at these boundaries? Okay, so we need plate boundaries, stresses, and faults. We can do this. So normal faults are due to tensional stress. So normal faults are due to tensional stress and can be found at divergent boundaries. So everything's spreading apart. So normal faults, tensional stress, divergent boundaries all go together. If we come down to reverse faults have compressional stress and they come from convergent boundaries. So reverse faults, compressional stress, convergent boundaries. And then the last one, strike slip faults are from shear stress and have transform boundaries. So strike slip, shear stress, and transform boundaries. And those are all 3 going to be right here on this second page. So again, normal faults are tensional stress and divergent boundaries. Reverse faults are compressional stress and convergent boundaries. And strike slip faults are shear stress and transform boundaries. That's how they all relate. Number 8. Oh, I hit the wrong thing. Here we go. Number 8. Which type of plate boundary is associated with very strong or deep earthquakes? What type of stress is associated with these earthquakes? What type of faults? So we kind of talked about this. In order to get the really big earthquakes, you've got to have a lot of bending. I need a plate to be pushed underneath another plate, and I need one plate to be bending a lot. Because that bending is going to build up all my stress, and when it releases, that's what gives me my earthquake. So I need a convergent boundary to happen. That's what I'm looking for here. So which type of plate boundary is associated with very strong and deep earthquakes? Convergent plate boundaries are associated with very strong and deep earthquakes. What type of stress is associated with these earthquakes? Compressional stress, because it's coming together, they're converging, they're going to be squeezing those rocks. That's going to be compressional stress. And then what types of faults are these? The faults are small scale, plates are big scale, but the type of fault would be a reverse fault, where you're squeezing things together, something's going up top of the other one. So we have convergent boundaries, compressional stress, and reverse faults are the types of things that are associated with very strong and deep earthquakes. Okay, number 9, earthquakes are caused by plate movement and displacement along faults. What are some other causes of earthquakes? I believe they go through that in here. So obviously plate movement is going to be your big thing. If we go back to number 1, page 1, they talk a little bit about earthquakes. I'm thinking things like, are we on page 1? Yes, we are on page 1. I'm thinking things like rock slides. Let's see. What else do they have here? Tectonic plates, earthquakes and tectonic plates. We talk about anything else. So landslide can cause an earthquake. A volcanic eruption can cause an earthquake. What else? I guess an asteroid impact could cause an earthquake. Yeah, plate tectonics, plate
Groundwater
tectonics, plate tectonics.
extraction.
Yeah, that's getting a little bit modern, but groundwater extraction can cause your ground to sink, which cause an earthquake. And the opposite, the same thing. Wastewater pumping from oil and gas services. If you put water in the ground where it's not supposed to go, you can expand the ground and cause an earthquake. Yeah, I would just give those three maybe. That's pretty good. Landslides, volcanoes, and yeah, you can put removal of water, groundwater extraction. That'll be fine. Okay. Now what? I feel like we're getting close here. Number 10, the final answer of the final countdown. Number 10. What do we have? What type of stress is associated with the San Andreas fault system? Describe how rocks move relative to each other during earthquakes along the San Andreas. What type of fault is the San Andreas? So we've kind of talked about this in the original lecture. San Andreas is the type of fault where nothing's going up or down. They're just sliding next to each other. So I talked to y'all about how California, like the movie industry loves to talk about California just falling off the side of the country and just going off into the ocean. But that's not how the fault works. That section of California, which includes LA, is just going to move up the coast as it goes north. And it's actually going to get closer and closer to San Francisco. So the type of fault where you're just sliding back and forth next to each other is, if we're talking about fault systems, first thing they ask is what type of stress? That's your shear stress. It's not compressional because I'm squeezing or tensional because I'm pulling apart. It's shear. It's going like side by side, right next to each other. Almost like, as anybody, I'm sure if you work in ag, you've heard the term shears, but you've heard scissors called shears. That's because they don't like squeeze stuff. You're not like pinching it or ripping it apart. You're actually slicing it by these two things going right next to each other. And so shear kind of makes sense with scissors. So what type of stress is associated with San Andreas fault? Shear stress. Describe how rocks move relative to each other during earthquakes on the San Andreas. They're just going to move horizontally. I wouldn't really give a direction because it depends on what type of the fault. But I would say they move horizontally in opposite directions. The rocks move horizontally in opposite directions. That's what's going to happen in an earthquake of San Andreas fault. And then what type of fault is the San Andreas fault? That one, if you go back to, what was the faults page? Number 2. That they will tell you that one is a strike slip fault. So all the way down here at the bottom, strike slip fault. That's your transform boundary, and everything's kind of going side by side with your shear stress. Yay! So that's number 10. Anybody want me to repeat something? Is everybody good? Make sure you hit submit. Don't worry about number 11. Just do 1 through 10. And whenever you're done, make sure you hit that submit button and get it turned in. And yeah, that's it for this week. Just real quick, I'm aware that we haven't taken any tests this 3 weeks. We could have taken one in here. I thought about getting a test together and reviewing yesterday and testing today. Kind of glad I didn't since so many people were out yesterday. But we will take a test when we get back fairly quickly. I just usually like to keep y'all matched up with my chemistry class so I can give everybody a test on the same day. And we've been running a little bit slow in chemistry, so that's why we haven't taken a test in here yet. But probably next week when we come back, I'll have a review for you at some point in time in that week, and we will take a test to get a test grade in the grade book. So, yeah. And I don't know what we're doing. I know I got a lot of seniors in here. I don't know what we're doing for the final exam. I'm thinking some sort of like little project kind of thing. Because if y'all don't know, we're not doing final exams the same way this year. For those of y'all that are not seniors, we're not going to have the half days at the end of the year that are just final exams. Yeah, it's just going to be regular class schedule till the last day. So 45-minute classes the rest of the year. We might still do a test, but we've been encouraged to ditch the final exam in lieu of like a project or something. That way,
Easier or what?
I mean, it depends on the teacher. Some teachers are going to pick hard projects, and some teachers are going to pick easy ones. It just depends. But I think the idea is you're not going to have that like 2.5 hour period at the end of the year to give that test. So unless your final exam can be done in like 45 minutes or over different days, then you can't really give a final exam. So maybe you do a project or something like that. So for those of y'all that are seniors, you'll probably get that pretty quickly, but I don't know. We'll see. It's all weird this year and crazy. So have a nice day.